In this lesson, we'll discuss several ways to represent linear non-proportional relationship. Okay, so let's recall what a linear non-proportional relationship is, and we can draw some contrast with proportional relationship. Okay, earlier we have studied about proportional relationship. There's also a different name that's widely used in other textbooks or in math, which is direct variation. If you may see this, is the same as a proportional relationship. Okay, and then we'll contrast that with linear proportional relationship, which is the topic of our discussion today. And in order to compare or contrast them, I'm going to look at two different things. One is the value of y over x, this ratio of one quantity to the other one. The other one is, if you draw the graph of these two kinds of relationships, does the graph, the line, pass through origin? Okay, so see if you can remember that. Okay, so for proportional relationship, what is y over x? Well, it's proportional, right? What does proportional mean? It means same ratio, and this is the ratio y over x. So y over x for proportional relationship is constant. Okay? But for non-proportional, well, because it's non-proportional, so you would expect that this is not proportional. Y over x is not a constant, so we use a variable to say that it changes. And I want to emphasize we're looking at the y over x value. So remember that when you had a table, you will have like x, and then you also have y. You'll be looking at the same pair. Okay, use that y value for that x, and then to find that ratio. And do not be confused with the slope. Slope is not y over x, okay? Slope, remember in the previous video, is the difference in y over the difference in x. So we can compare two y's from one point to another, okay? But to determine whether it's proportional or not, we just use one order pair, just 1 point to determine it. So it's different. Be careful with that one. All right, the other thing that I want to look at is, does it pass through the origin? So for proportional relationship, yes, it passes through the origin. And for non-proportional one, it does not pass through the origin. Okay, next thing we want to look at is how can we represent linear non-proportional relationship? Okay, there are several ways we can do it. The first one is by using a table. Okay, we can use the table to list the order pairs, the x and the y. You can either do the table like a t-chart where you list x on one side, and usually it's on the left-hand side, and then y depends on the x, which is listed on the right-hand side. That's the usual way to do it, like vertically. Or you can also have the table displaying the data horizontally, where x is usually on the top, and then y is on the bottom. Besides using tables, we can also use graphs. Okay? We can use a graph to represent a situation. So maybe from the description or from a given equation, we can first of all come up with a table like this, or use some data that's given, that's embedded in the problem, and then find some points, and then connect those points. Well, not all the time you need to connect. It depends on the situation. I want to emphasize that. So first of all, you will find the points, and you can use the points to join them up in some situations. Most likely that you will join it if the equation is like a generic equation. But for real life situation, you got to be very careful to determine if you need to join the points. So we will join it, and then we can see like a graphic representation of the relationship. Now the difference between table and graph, I think, is very obvious. A table, you see the numbers, right? And for graph, you have like a visual way to see the relation. Is it a line or is it curvy? Does it pass through any particular point? If it's a line, how steep it is. And sometimes we may also represent more than one line on the same coordinate plane, and then we can compare like two lines, which one is steeper, where do they cross each other, etc. So graph is a very visual way to display, to represent a relationship or more than one relationship. All right, the third way that we can represent a relationship is by using equations. Okay? And for linear non-proportional relationship, equations such as y equals to mx plus b is a very common form of equations. Now, this equation is for linear relationship, okay? And whether it's proportional or not depends on the b. Remember, we looked at proportional relationship. It was only y equals to kx. There is no constant term, right? Y equals a number times x, okay? And remember, in our previous lesson, we saw that m is the slope, which is constant for a line, okay? So for a proportional relationship, k is actually the slope as well. Okay, so it's y equals to kx or y equals to mx. However, if you also have a constant term, that makes the relationship non-proportional. Because if you look at y over x, you will not be getting a constant value using equations like this. And sometimes when you are given an equation, you can use this equation to first generate some points in a table, and then use these points to plot the dots and then to draw the graph. So let's look at one example. A gym charges $30 for initial sign-up and $20 per month thereafter. The equation y equals 20x plus 30 gives the total value y you pay to use the gym for x months. Okay, so before we look into the questions, let's study this situation. So it's a very common one. If you have ever had a gym membership, you're probably aware of that. So a lot of times you have to pay some dollar amounts to start with. Okay, it's like an initial sign-up fee. Okay, in this case $30, and then every month you have to pay extra depending on how many months you want to use their service. So you pay $20 a month. Okay, some people pay more, some less, depending on the gym that you joined. And it is represented by this equation. Now, for this situation, the equation is given for you, right? In some other situations, sometimes you have to figure out the equation on your own. But this time, this is given for you. And see if that equation makes sense to describe this situation. Okay, so let's see. If I just want to sign up and I have not decided if I want to start using their service, how much do I pay? Okay, that means I'm using 0 months, right? X is the month. But I want to sign up just to be ready. Okay, then I still need to pay $30 because Y, which is the total value that you pay, is equal to 20 times x. X is 0. You have not started using the service yet, but you just want to sign up. Then you still need to pay $30, right? 20 times 0 plus 30 is 30, so you pay $30. And what if I just want to use their service for 1 month? So x is 1. Okay, so you have to pay that 1 month, which is $20, on top of that 30. So the total of that, of course, is 20 times 1 plus 30, which is $50. Okay, so that equation makes sense to describe that situation. All right, so what are the problems that we have here? Okay, A, we will make a table to represent this situation. Okay, remember there are several ways to represent situation. Use the table. And B, we'll graph the relationship. Okay, see what it looks like on a coordinate plane. What is the shape of the graph? Okay, we'll describe the shape. And then we can answer, does it represent a proportional relationship? You might have the answer now, but we'll still verify using the graph. And then see how can you use the table to determine if the relationship is proportional or not. Now, in part B, we use the graph to decide whether it's proportional or not. But again, we don't have to use the graph to make that decision. We can use the table to determine if it's proportional or not. So that's part C. Okay, so let's start with part A. All right, I want to generate a table. So X represents the months, Y represents the cost. Because first of all, it's like given in the situation, in the problem here, right? It already says that X is the months, Y is the value. If that is not given, you can still make the same choice. Why? Because X controls Y and number of months controls how much you pay. X is the independent variable, Y is the dependent. And we usually write the independent on the top, X, Y, or number of months, cost, like top and bottom like that. Okay, so how do we populate this table? Of course, we will use the equation to help us populate this table. So we use the equation to evaluate Y for each value of X. So let's say X equals to 1, right? X equals to 1, then Y is 20 times 1 plus 30. Okay, my stylus is really hard to write, which is equal to $50, okay? And when x equals to 2, in this situation, y is 20 times 2 plus 30, okay, like that, okay? And that is 70, okay? Likewise, when x is equal to 3, then I will have 20 times 3 plus 30, okay, which is equal to 90. And lastly, 20 times 4 plus 30, that will give you $110. So this is how much you will pay. And then we are done. We are done making a table for this situation. All right. So next one is to graph the relationship. How do we graph the relationship? Now that we have a table, we can just use these points. This is this point here, x is 1, y is 50. So I'm going to use this pair. This is like 1, 50. And this point here is 2, 70. And then this is 3, 90. And lastly is 4, 110. I have 4 order pairs. So I can use these order pairs to graph the situation. So this is what I have. Okay, so these 4 points here corresponds to these 4. Okay. So what is its shape? What does it look like to you? All these points. Okay, you may see that it looks like it's a line, right? So if you would connect these 4 points, it will be a line, right? So the shape is a line. And does it represent a proportional relationship? What do you think? Does it represent a proportional relationship? Remember, to use a graph to determine whether it's proportional or not, we will look at if it passes through the origin, right? So if you would like connect these dots, continue, do you think it will pass through the origin? Doesn't look like it, right? It does not pass through. So in this case, this is not proportional, okay? So this is non-proportional, okay? Okay, I have a question for you now. You see that I use like these 4 dots on the graph, and I did not connect the dots. So my question for you is this, okay? Should we connect the dots? What do you think? Is there any difference if we connect the dots? Well, the answer is yes, there is a big difference, okay? If you would connect the dots, of course, you will get a line, okay? But then you are also saying that every point on the line, even those points in between the 4 dots, okay, even the other points, and there are infinitely many, okay, such points along that line that you would get by joining these 4 points. You are saying that all these points, that infinitely many points, can be used to describe that situation. Now, is that true? While you're being charged month by month, will you be charged for 1/3 of a month? If I only use the service for 1/3 of a month, do they do prorate membership fee? If they don't, then you can't count like 1 1/3 of a month, or 2.5 months, and so on, or 6.1 month, right? So those values are not allowed. So in this case, we assume that because in our real life situation, Jim is always like, month by month, so we only have like these dots, okay? And see, how can you use the table to determine if the relationship is proportional or not? Now, without looking at the graph, of course we can use the graph, but now without looking at the graph, how can we use the table to make that decision? Again, we can use the y value and the x value. Remember, proportional relationship, they have equivalent ratio. If we look at like y over x is always constant, right? What is y over x for the first pair? Y over x is 50 over 1. What about the y over x for the second situation here? It's 70 over 2. Okay, so let's examine that one. The first one, okay, let's look at this. I have 50 over 1. The other one is 70 over 2. Are they the same? They are not equal, right? And because it's not that all ratios are equivalent, so this is a way to determine that this is a non-proportional relationship, okay? Just like the same conclusion that we have drawn from looking at the graph. Lastly, a very quick discussion on linear equation. We'll spend more time on that later in the class also. Okay, linear equation. Okay, a linear equation is an equation whose solutions are ordered pairs that form a line when graphed on a coordinate plane. Okay, so what does that mean? So basically, it's an equation, and for an equation, you also expect solutions for that equation. Okay, and the solution of the equation are actually ordered pairs. Okay, and the ordered pairs form a line when you graph it on a coordinate plane. So look at one example. Y equals to 2x plus 5. How do I find the solutions of this equation? Okay, how do I find the solution of that equation? Why don't we compare to the things that we have learned before? So if I ask you, how do you find the solution of this equation? Let's say 5 minus x equals to 2. How do you find the solution to that one? Well, probably you know the answer right away. The solution is x equals to 3, right? You can do some operations to find out what that is. So you say that x equals to 3, and that is the solution. What does that mean? That means if I plug in x equals to 3 in the equation, then the left-hand side will evaluate to be the same as the right-hand side. If I plug in x equals to 3, left-hand side is 5 minus 3, which is 2, and 2 equals to 2. That means this equation is a true statement. If I plug in something else, if I plug in 0, then left-hand side will obviously be 5, and right-hand side 2. If I say 0 equals to 2, then I just make this statement a false statement. Okay? So solution basically is the value or values of the variable that makes the equation a true statement. So now going back to this linear equation, we have two variables, y and x. So what are the solutions? Well, it depends. Could x be 1? Let's say, okay, so could x be 1? If x is 1, then what is y? Well, 2 times 1 is 2, and 2 plus 5 equals to 7, right? I just plug in x equals to 1, and then I just got y equals to 7. That means this pair, this order pair, is a solution. I can plug in 1, 7 to make this equation a true statement, x being the 1, right, on the left-hand side. That's why it's called an ordered pair, okay, ordered, because the position of the variable matters. The first one is always the x, the second one is always the y. That's why it's called ordered. So this is plugging for x, and then this is the y. If I plug into this equation, then I see that left-hand side 7 equals to the right-hand side 2 times 1 plus 5, also 7. So 1 comma 7 is one solution. Likewise, I can also find another one. So let's say x equals to 4. And what is y? 2 times 4 is 8. 8 plus 5, 13. This is also a solution. Or I can also have, what about x equals to negative 1? Then y will be negative 2 plus 5, which is 3, right? Or I can say x is 1/2. Then y will be 6. So you see there can be many solutions. In fact, there will be infinitely many solutions. You can plug in any x and then get the y. Sometimes I know the y, I can use that to evaluate the x back. So how many solutions? It can have infinitely many. Does it represent a proportional or a non-proportional relationship? So in this case, just by looking at this equation itself here, I can see that it is a non-proportional, because for proportional one, there shouldn't be a constant term. It's just y equals to a constant times x. But now I have this 5 that makes it a non-proportional relationship. So this is non-proportional. How can I make it proportional? It's very easy. I just need to take out the 5, only leave the y equals to 2x, and that will be proportional, right? Or I can say if this constant term is 0, if this is 0, then it would be a proportional relationship. How can I graph this equation? Okay, it's very simple. The first thing is come up with some points like I got here, right? And then you can just like plot those points on a graph paper and then join them up. Or you can use a table to list all these points and then to join them up and then you get the graph. We'll have more discussion on working with a linear equation later. And again, this is just one of the many forms of a linear equations. Down the road, you'll be learning different forms of linear equation, but they are all equivalent to one another.